Hey everyone, so this is kind of a lesson slash examples, I don't know what to call this, of curve sketching when you only know f prime or y prime. So I'm going to show you an example and then I'll have an example for you to try just to kind of get through this. So here's the idea. What can you confidently sketch about these curves? This is the motivating question. And what you're going to be given here is just f prime. And so this is what you have to work off of. So you're not being asked to figure out what is f, the original function. You're just starting with the derivative. So let's think about this. Can I determine the critical points? Absolutely, right? So I can totally set this thing equal to 0 and I can solve it no problem. So I can just factor this and I will find that my critical points are x equals -2 and x equals -3. Now here's the plot twist. If you only know the first derivative, then it's not like you can plug these in to actually figure out, what points these are on the original graph. So you just know that these are the critical points. Now, can we figure out intervals of increasing and decreasing from this? Also, yes, right? So maybe what I want to do here, first I just want to write this out as x plus 2, x plus 3. I always find that's helpful when I'm coming up with my tables. So let's go ahead and make a table so that we can kind of classify our increasing, decreasing intervals. So I'll set that up. And so now we can totally figure this out. Sorry, that's a terrible prime symbol. Okay, so I can go ahead and plug in kind of test points into this, right? Or I can choose I can't think of the word right now. You know what I'm talking about, a dummy point. So something in this interval, so something like -4. If I were to plug that into the first derivative, so -4, that would make this something negative times something negative, so this would be positive. If I chose something in between -2 and -3, so let's say -2.5, so -2.5, this would be negative, but this would be positive, so this whole thing will be negative. And then if I choose anything bigger than -2, so let's say 0, so this will be positive times something positive, so this will end up being positive. So I can figure out my intervals of increasing and decreasing, and then also based off of this information, given what I have, I could say that, these are max or mins, right? So this, at 3, we're going to have a max, and at -2, we're going to have a min, so I can summarize that. Okay, so we've got that going for us. Now, like I said, the only thing is I can't figure out exactly what points these occur at, right? Because I can't plug these back into the original function f. And that's okay. We're just going to do the best that we can with this information. So now, can I figure out inflection points or potential inflection points from this? Yeah, I totally can, right? So what I'd have to do for that is I'd have to figure out what is the second derivative. And that's no problem, right? So I can just do that. So that'll be 2x plus 5. And I can totally figure out where that equals 0. There will be no place where it's undefined. So let's see, I'll have 2x equals -5, divide both sides by 2. So I have this potential inflection point at -5/2. And from this, I can figure out my concavity, right? So once again, I'll set up that table. And so now, if I just rewrite out what my f double prime was, so this was 2x plus 5, just for reference. So now if I choose something, so let's see, -5/2, that's really -2.5. So if I choose something like, say, -4, if I plug that into this, this will end up being something negative. And then if I choose anything above this, say 0, this will be positive. So yeah, we can say that -5/2, that is an inflection point. So let me just clear some space and I'll just write that out just to summarize. Okay, so let's now just summarize what we know. We said that there is a max at x equals -3 and a local min at x equals -2, and then an inflection point at x equals -5/2. Now, like I said, it's not like I can just plug these back into the original function. So what I'm going to have to do then is just kind of sketch to the best of my ability. And I also want to make sure that I'm using things like what I know about increasing and decreasing, and also my concavity. So if I think about this, my graph needs to start off increasing, up to -3, and it will decrease from -3 to -2, and then it will start increasing again from -2 on. Now on top of that, so between -2 and -3, we have this inflection point. So let me show you the other one. This is -2.5, so somewhere in between we also should have this inflection point. So I just need to make sure that all of these things are represented. So I want to start by making sure that I have a graph that's increasing all the way up to -3. Now, since I don't have any idea what my y's are going to be, again, this is just kind of a sketch. So I just kind of drew this x-axis as just kind of a governing as a guide here. So here's where -3 is. And so I'm just going to increase to -3. And now I'm just going to kind of mark off a couple other points. So here's -2. So let's see, why don't I just put that here? And then we'll put this, here's my inflection point somewhere in here. So it doesn't even matter where you kind of draw these, you just need to make sure that everything's reflected. So if I wanted to put like -3 up here, and then maybe put my -2 down here, and then here's my -2.5, like this is fine. You're just trying to sketch the best graph that you can with the information that you were given. So here I'm supposed to be increasing, from here to here I'm supposed to be decreasing, and then from here to here I'm supposed to be increasing again, right? So let's just make sure. So increasing, decreasing, increasing, and then I need this inflection point at -2/5. So let's see, I can definitely see we're changing from concave down to concave up, so it looks like I'm good. So you're just trying to get this general idea of the graph as close as you can with the information that was given. So there's going to be some limitations to it, so try not to overthink it too much. And I think just having something like this can be helpful. Okay, so if you found that helpful, maybe consider giving my video a like or subscribing to my channel or leaving me a comment. That super helps me out. And I have one more example here for you. So if you want to try this out, you can kind of go through the whole thing and hit play when you're ready, and I'll walk through the whole example. So maybe pause here, hit play when you're ready. Okay, so I have this whole thing. So this form is nice to see. However, I know that I'm going to have to take a second derivative. So while I'm here, why don't I also just work this out? So this is x squared minus 4x plus 4 times 2x plus 1. And then I can just multiply this all out. So let's see, this is, 2x cubed. Let me just multiply this all out. Okay, so I've multiplied all that together, and if I collect my like terms, so this will come out to 2x cubed minus 7x squared plus 4x plus 4. So I just want to note this for later on, because when I find the second derivative, this might be helpful to know. So we'll just get that work out of the way. Okay, so we'll keep it in this form for now, because this will make finding my critical points pretty simple actually, since it's already factored for me. So I can see just by looking at this, I'm not going to have any place where this does not exist. And then where this will equal 0, it will be either 2 or x equals -1/2. So there are my critical points. So now I can come up with my intervals of increasing and decreasing. So let me make my table. And so now we can figure this out. So let's see, if I choose something, let's say like -1. So this will end up being positive, and this will end up being negative. So this will be negative. If I choose something in between -1/2 and 2, maybe something like 0, so this will always end up being positive because we're squaring it, and then this will be positive, so this will all be positive. And then finally, if I choose something like, I don't know, 5, this will still end up being positive, and then this will end up being positive. So here I am. So now looking at this, I can see that it looks like, so -1/2, I'm going from decreasing to increasing. So this is probably a local min, or min. And then at 2, well, I don't have that, right? So can't be either. Okay, so now let's talk about our possible inflection points. And so this is where I just want to remind you of what we found for this expanded version of f prime of x. So that's what I found from before. So that's going to make finding my f double prime just a little bit nicer. So this is 6x squared minus 14x plus 4. So let's see, can we factor this or anything? So if I set this whole thing equal to 0, so this is 6x squared minus 14x plus 4. So let's see, I can definitely factor out 2, right? And then let's see, is there any way I can arrange this? Yeah, this will totally factor. So let's see. I just need to make sure I bounce this off of the 2 and this off of the 1. And so then this will give me, so 3x times negative 2 is negative 6. And then negative 1 times negative x will give me that negative 7. So here we go. So now I can find my possible inflection points. So I'm going to have x is positive 1/3 or x is positive 2. Okay, so now let's go ahead and figure out a concavity. And I'll write out that factored version of f double prime of x because I just think it's going to make it easier to figure out what's positive and what's negative. So let's see, if I choose something like 0, it'll give me a negative times a negative, so this will be positive. If I choose something between 1/3 and 2, so maybe something like 1, so this will be positive, but this will be negative, so this will all be negative. And then if I choose something like 5, this will be positive and this will be positive, so there we go. So now I can see that I have an inflection point probably at 1/3 and at 2. Okay, so once again, I want to kind of just round out all that information now. So we said before that it seems like I have a local min at x equals negative 1/2. And then we said inflection points at x equals 1/3 and x equals 2. So now let's see what can we do with this. And actually, just maybe for funsies, I'll also just note that I had a critical point at x equals 2. Okay, so at negative 1/2, so here's where I'm at 0. So here's negative 1, so negative 1/2, we'll just put it somewhere here. So I know that I'm supposed to be decreasing to negative 1/2 and then increasing from negative 1/2 to 2. So going back to this, so here's my negative 1/2. So I'm decreasing to this point, and then I need to increase to positive 2. So why don't I just put positive 2 here? Now, the other thing I have to worry about with this is also my concavity. So I know at negative 1/3, I need to have a change in concavity, and then also at 2. So let's see, where is 1/3? 1/3 would be somewhere around here, and from here to here I need to be increasing, right? So now what I have to do is so let me just see if I can kind of do this. So I need to be concave up from here to here. Now I need to see a change in concavity without, okay, that looks terrible. Let me draw that again. Let me maybe make my negative 1/2 just a little bit further down so I can exaggerate this a little bit more. So what I need to have happen is I need to make sure that 2 is shown as an inflection point. So let's see, here's 1, 2, so here's 2. So I need this to be an inflection point where I have this change in concavity. So this needs to change to concave down without it actually being a max or a min. So this is a little bit tricky to draw, so it might take you more than one time to kind of wrap your head around it. So I'm going from decreasing, decreasing, and then here at 1/3 I need to see this change in concavity. So I go from decreasing and I'm concave up, and then here I need to switch to concave down. Okay, so let's see if I can just smooth this side out just a little bit more now. Okay, so now I think I finally got a good sketch. So you need to kind of reflect this in such a way so that this doesn't look like an actual max or min. So maybe you want to just kind of flatten this out. So you can flatten this and have the concavity change without it really being a max or a min here. And if you think, oh, this doesn't exist, this has to be a maximum or whatever, you know, I can't draw it like that. So this is kind of the same idea if you think about the graph. So maybe I'll just show you one other graph where this works like this. Oops, sorry about that. So the other graph where this works like this would be something like f of x equals x to the 3rd. So if you think about just this graph, this is a really simple idea. So if you start taking derivatives of this, you would get that 0 is a critical point, but it's neither a max or min because it's an inflection point. So it's the same idea here. It's just a little bit harder to draw because it's a more complicated function. So that wraps this up. Thanks for watching, guys, and I'll see you next time.